on there.
Ah, is it?
That's what I was trying to say before. Because it won't work.
Trial and error. You have to test dummies anyway.
Yeah, nice.
We are testing things, so I'm actually making myself ready for next year. You see?
So you just trialing.
Oh, okay, we see.
Hopefully we'll see. Or we'll see, I don't know. Alright. Questions? Yes, thank you. Calculate the strength of the electric field. The strength of the electric field between the plates include an appropriate unit. Now, the distance is provided, the voltage is provided. It's a simple application of E equals V over D formula. It can't get any easier than that, right? Cannot be any easier than this. And if you lose marks, it's a 2-mark question in here, it will actually be hectic. You can actually lose marks. You can actually lose marks in the divisions here. I mean, they even give you that. It looks like it's going to be 10 to the power 1, 2, 3, 4, 5. 5 volt per meter. Volt per meter, right? 10 to the power 5 volt per meter.
Can't you just write 100,000?
Yes, you can write 100,000. Moving on. Calculate the speed of the electrons as they exit the electron gun. This is the time that we are going to use our V equals, is that
2Q
V over M formula. Again, in this question, I can't use my method, my shortcut method, because it's not a multiple choice, so I don't have choices to choose from. That's why I have to be very careful, very careful. 2 times 1.6 times 10 to the power minus 19 times the magnetic field 0.02, 0.02. Yeah, they're following, that's right. 10,000 volts divided by 9.1 times 10 to the power minus 30 or 31? 31 kilogram in square root will give me the answer as 2 times 3.6 divided by 9 is like 1.9 something?
5.9.
5.9
times 10 to the power 7.
times 10 to the power 7 meters per second. Now this is very close to speed of light, because if you remember, speed of light is 3 times 10 to the power 8 meters per second. So this is 0.6 times 10 to the power 8 meters per second. It's almost 20% of speed of light. Yes. Can you see? This is 20% of speed of light.
So our answer should be as close to speed of light as possible. No, like when we work it out, like it should make sense.
Yes. It shouldn't be more than speed of light.
Yeah,
it can be close to speed of light, but it can't be the speed of light or greater than speed of light. That's like the net, safety net. So you can check it. And if you have this, that's wrong. Because it says it can't even travel 1 meter in 1 second. Right?
Yeah, which is.
It's not negative. It's a very, very small number. Right? Yes?
Would your answer please be 5.9 or 5.93? How would you do your significance?
Depends if the question provides you 2 significant figures here.
So it's 5.9.
So 5.9 should be alright. 5.9 should be alright. Yes?
For example, Tesla is 0.020.
Still 2 significant figures. This is 2 significant figures.
Do you assume initial velocity is 0 if the
Yes,
electrons
yes,
leave the
yes,
gun?
yes.
Okay.
In this setup, the initial velocity is 0 because you heat them up. Alright? But you can actually, what you can do is you can actually have another set of plates. Alright? And the ones here can be accelerated. Then the initial speed won't be 0. But I don't think they will make it that hard. Alright? The electrons next enter the region of uniform magnetic field. Calculate the radius of the path of the electrons. Again, a simple application of R equals M times V over Q times B that is 9.1 times 10 to the power minus 31 times velocity, we find it as what?
5.9 times 10 to the power of
7 squared divided by 1.6 times 10 to the power minus times 0.002.
So is the radius in the answer we find is meters, right?
Just for a second. If you stick to the standard units, you don't need to worry about the units at all.
Does it make sense?
0.02.
So I got two mistakes here. Which one? First one is?
Negative
Isn't
19
it?
and
He's not
0.02.
purpose.
Yeah.
Negative 9.
You wrote negative 8. 8 of that on purpose?
Yeah, because like I've got 2 mistakes here.
Because he said it really clearly, so it's kind of obvious he knew about it.
Yeah.
0.00.
Oh my god, this question keeps going wrong.
Alright, thank you. And the next part is in another part of the particle accelerator, the electrons are deflected by a uniform electric field as shown in figure 2.2a. Yep, that's alright. And by magnetic field as shown in figure 2.b. Alright? Explain why the paths of the electrons in the two fields have different shapes. That's a good question. That's a good question. Why we have different shapes? Why the electron is not making a circle in here?
Because the force.
And why the electron is not deflected? You'll see, it's not a deflection, it actually goes through a circle and comes back. In a magnetic field, it kind of does a circle, whereas in an electric field, it just
Minister, could that please
deflects.
come to front office for
The amount
ordering?
of deflection may differ, but it is being deflected. Yes, Dira? So why do we have this? Now remember, I told you that electric field is always either up or down. Is that right?
Yeah.
So if we look at the electron at here or at this point, where its velocity changes, what about the force? Look at the force. It was down, it's still down. It's like gravity. It's not like this all the time, girls. Alright? It's changing. As the velocity changes, the force simply says, I don't mind, I don't care. Whatever the direction of velocity, I'm going to be down. Right? And hence, you have this deflection. But when you look at the magnetic field, when the velocity changes direction in a magnetic field, the force says, look, tell me what you are, and I'm going to organize myself accordingly. And if the velocity is in that direction, force stays at right angles. Velocity changes direction, force stays at right angles. And again, force at right angles and points the center all the time. So, in magnetic field, force is always perpendicular to the velocity, whereas in electric field, force is in one direction all the time. It doesn't align itself according to the velocity in electric field, whereas in magnetic field. So, electric field, the force in electric field is down always. Always. It's like gravity. Right? Gravity is like this. It's always down. Right? Gravity doesn't change direction. It's always down. Whereas in magnetic field, it is always right angles to the velocity. Alright? So that's why velocity, force, or that way, that's why that makes the change. In electric field, the electric force is in one direction. Either up or down, doesn't matter. But whatever the direction, it maintains the same direction, ends up this. Whereas in magnetic field, the magnetic force changes direction, which doesn't happen here. Changes direction and aligns itself at right angles to the velocity, causing this circular path. Because when this happens, should we go? What we had. When this happens, no. I should point this to someone else today, not Shafika. Shafika did great in the quiz. Maybe or maybe like that.
It's the wrong way, Rachel. It's the wrong way of saying.
After that,
Parents just walk past and
so it's going to be inverted in the video, Elif says. Anyway, yes, when we have this, girls, we have circular motion. Alright, remember this. We have circular motion. Alright, how about that one?
I cry when I laugh. We don't speak normal. Quite normal. My dad.
Alright.
So what formula do you use for this?
The electron gun, electrons are accelerated from an over a distance of 12 centimeters to reach a final speed of this. Question: what is the accelerating voltage? Remember the formula that I know relating velocity to voltage is 2qv over m. Now, providing the distance is just to confuse me. It's a confusion. You don't need that.
You don't need it.
Because you already know the voltage. Oh, sorry. You already know the velocity. You can solve it for voltage. Because the voltage is going to be mv squared over 2q, right?
Why is the voltage and the velocity the same sign? It's just so annoying.
Just to
There's
make
not enough letter for
harder
me.
so that,
No, voltage is
So that-
therapy and
so that girls
velocity.
don't choose physics. Just to make it scarier for people.
They never use X.
Anyway, but I'm trying to make it as large as possible, the y and the v as small as possible to minimize the confusion. Just sometimes just they put a hat here, velocity. You do that. Alright, girls. You see, the 12 centimeter is provided as a confusion. Alright, you don't need that. You don't need that. This is the formula to find the velocity. It says ignore any relativistic effects. Hopefully, when we start talking about special relativity, we won't be ignoring that. Moving on. A magnetic field of 4 times 10 to the power minus 4 makes electrons traveling at a speed of turn through a part of a circuit. Alright? So the magnetic field is provided and velocity is provided. What is the radius of the circuit? Come on.
Well, let's skip it. 8.
Will be NV divided by QB. A simple application. Can I use my shortcut method?
Yes.
I can. There's 1.9 and 1.9. So you have that.
No, you can.
But it's
One
just
centimeter, one's meter.
Yeah, I know exactly. How you gonna know which one's
Oh,
which?
yeah, true.
Say it.
It's gonna be in meters anyway.
Yes, but careful. When I use my method, is 9.1 is the mass, velocity 8 divided by Q 1.6 and quite close, and magnetic field 4. This is going to give me what? 1.1?
Yep.
1.1.
This it actually gives you 11.
No, you get.
This thing gives you 11.
So I don't get. How do you do it?
Sorry?
How do you do it so fast?
Because I know the answer should be either 1.1 or 1.1, so I assume.
How do you know that?
But you see, this is 9 times 8 is 72.
Yeah.
And 4, this is like 6. 7, 6 is 11 something. Look, so I use this method now. Is that right?
Yeah.
Because, girls, careful, which one? Is it 1.1 meter or 1.1 centimeter?
1.1 meter.
How do I know? My answer is 11. I have to work out the powers to get this thing. Finally, the magnitude of the force acting on these electrons, that will be 2 times 3
Do you have a
times
quiz next week?
B. We will have a quiz next week from electric motors and maybe a little bit
So is that
of this.
5.1?
Your homework is, I will tell you your homework, and I will fill the have it.
Hi guys. It's the recording. Today we visit
Like chicken.
and now
Elif, you stay. Elif,
Yeah.
you say that you ask me a question. Yes?
So is it a possibility that you could be as
That will go. That will for sure.